This is the Nephew SDK meeting for March 5th, 2024. So for me, as I said on the chat, for folks who actually read it, I wasn't able to make as much progress as I would like for the, quote unquote proxy operator. So I'll get that going. The goal there is I'll try to hook up the back end with Helm to see what the gaps are. In terms of, so we anticipate at least attempt to use Vim's K, what do you call it? K form, I think, would you say? When it
yes, think of Terraform and for Kubernetes.
Yeah. when it becomes available. So in the meantime, I just want to know, in addition to executing a DAG, which is based on the transformation of your resources, is there additional things that are needed in order to bring up the network functions through Helm? And then we'll see what kind of interface that we're supposed to be using in terms of the execution context and things. So I'm working on that. I was hoping to finish it today, but I wasn't able to. So that's why I was. So that's my update on this side. So I guess before I joined the meeting, because I was thinking when I should cancel the meeting, but before I joined the meeting, I guess Vim was talking about making your code available.
Yeah, so I started the thing in Nokia, right, to get it out of the company, right? What we can do probably, I mean, I anyhow need to do some documentation and stuff like that. Tomorrow, I will also show it, but there it runs in as part of specialization, by the way. So it's a bit, I mean,
different.
It also runs in a controller, but it actually, it does the same as you saw on the client side, right? So the thing is, so what I demoed to you was basically raw access to data, right? And it executes, but in the package, it's the same, basically. So you run it.
So in our case, your K-form runs with Nephew SDK wrapping it in one side, and that would generate the DAG, and then we have to load that into the image, and then
so it always runs. So in all the cases, it executes a DAG, right? So that's not any different. The difference between, so in client side, okay, you just run it from the user. In package side, you just run it when specialization needs to act, right? So that's
so in our case, the SDK basically just generates some sort of includes some sort of YAML, and then during runtime we execute your code, and then based on that YAML, it generates a DAG and it executes that. Okay.
Yeah, so we need to find so as we were discussing last week, right? We need to have a hook inside of the controller, or at least that would be my proposal.
So I'm writing that proxy, but I need to know what the interface looks like in terms of generating that hook. So we'll do that when the code becomes available. That's okay.
Yeah, but you could just do hello world, right? So if you just
in the meantime, right now, I just want to I want to run what Fiacre and others did in terms of Helm on the operator. So I just want to see in terms of, because that even the Helm controller or Flux is not, it's one of the options, right? It's not a required thing. So we want, so this will be brought in by vendors, and I want to see, in addition to doing transformation of resources, is there some other things that we actually needed to be done on the execution hooks. So that's basically more or less that POC to make that going. So get that going. If that works, plus your stuff, and it will be one level of integrations. I guess so. Once you have them, then we'll know what the interface looks like, and then hook it up. I guess we'll see the demo tomorrow, which is on specialized.
Yeah, tomorrow is a bit different. It's more focused on the management side, right? So it's a bit of a different, but the logic is always the same. So there is no difference with it.
Yeah. Okay. Go ahead, Fiacre.
Could I ask a noob question? When you refer to, is it a deck or a DAG?
A DAG. I don't know.
DAG. A directed graph.
Directed
graph. Yeah.
Okay. Yeah. Thank you. Thanks.
A DAG.
So I'm guessing it's more like it's like Apache Airflow that you have the executions when we run a set of tasks when a graph nodes get hit. Is that what happened?
Okay, gotcha. Sorry, new
What's
question.
the right
Thank-
pronunciation, Fiacre? Is it DAG or DAG?
Da-
DAG?
Dag.
DAG,
Sorry,
Dag.
no,
DAG.
Yeah,
my
dag. Yeah,
dag. Yeah,
Okay.
dag.
that's the Irish
I
pronunciation.
guess even
Dag.
even I pronounce it wrong. I mean, I guess that's the problem. I say dag. It sounds like DECK dag.
Yeah,
which
these
is,
European guys.
uh, so that's good. We can hopefully get that soon. But then in the meantime, there's still stuff that I could do to make sure that we can execute the flux things to understand what the we're not there's any gap, or if we actually hook it up with your DAG that way in terms of I know there's one more resource that needs to be loaded into the system, but anyway, so that's okay.
But you can also test it offline, right? So you could even, I think even in this case, I was thinking, because so there's a plugin framework, right, in Kform, right, which is basically what Tal I used as well. So there's this HashiCorp. So a provider is basically instantiated through a gRPC service at the end of the day, right? So what you typically do in Terraform when you create a provider, that's what happens, right? So you basically say, okay, I have a provider, so you get executed through the DAG, the DAG or the DAG,
DAG,
and the DAG, yeah, and so it will call the gRPC call, right? So maybe we should write a Helm provider, right? That basically takes the Helm what we have today, but it's a wrapper just to trigger it.
Okay.
It would be that code is kind of maybe 100 lines, less than 100 lines, to do something like that.
Okay.
Then it's natural, right? So you basically at the end, when you have all the parameters, right, you just call that provider to say Helm, bang, and then you just run it. So we don't change anything of Helm. It's just the instantiation. It's part of the whole ecosystem.
No. So we never want to change anything in Helm. It's just that we have to do our preparations when we get to that point where Flux can take over. Okay. That's why I try to explore. So that's great. We can check it out too.
But I think is Flux not having a CRD?
Flux is having a CLD for pointing to the pointing to which Helm charts you're going to. So they don't represent the values.yaml obviously as a CLD. That's just a config map.
Yeah, correct. So, but there is two ways. What I'm trying to get to. I've not played too much with Flux, but so what do you do to instantiate the Flux? So normally you give it value.yaml and a pointer to the chart.
So you load a config map. You point to your config map, and then you load a CL, which is a Flux specific CL. It tells them that I'm ready to deploy this Helm chart. So point to that Helm chart.
So in that case, so the only thing we need to do is spit out those two things from the DAG.
Okay.
Right. So basically, if we say this is the config map which represents the values.yaml, and here is the CR that points to the repo that config map. That's then the Kform pipeline needs to just render those two things, and then that's the output of the run, right? And then Flux takes care from there.
Right.
Is that not simpler?
So wait. So one side we still need to listen to NF deployment.
Yeah, correct. So that's what
that
DAG
happens.
will do. The DAG will do, right? So the DAG looks at NF deployment, it does its business logic, and at the end of its business logic, it spits out your
but then the watch you still need to write the watch, right? So that's what we talked about last week. So we write a proxy operator, so that executes the DAG.
Correct.
And then that at that point, the execution of the DAG give us the config map generations.
Yes.
And also, I would imagine it wouldn't be that hard to generate also the Helm
correct.
the Helm locations and things CLs.
Correct.
And then we applied that, or the DAC applied that, and then at that point Flux should take over. So that's what I expect to happen. Also, it shouldn't be much more than that. Hopefully, I mean we work on status and all that stuff later, but then for now let's make sure that create flow, at least the execution on one direction is working, and then after that we may have to pull statuses off of Helm or something. So
Yeah, which you can do as well, right? Not a problem. So, but yeah, so in other words, what we spit out of the DAG is those two CRs basically, right?
Yeah.
Which one is a config
Correct.
map and then something else. So yeah, that's half an
Yeah,
hour.
I don't anticipate anything hard right now. I'm writing some sort of dummy thing to just do this before waiting for your stuff to happen, and then we'll see what other if there are any other gaps there is to it. But yeah, so that was the exercise that I was hoping to finish today, but I wasn't able to. So sorry. So cool. Once you have that, it will be nice to have some sort of walkthrough to see how we hook it up.
Yeah.
Then I guess you show
But
that
maybe
tomorrow.
we should write down what we just said, right? Maybe it's
Yeah,
also
that
okay
too.
to write
That
it
too. Yeah, that
because
too.
it's probably. I mean, if someone wants to do it, that's okay. Otherwise, I can review it. But yeah, I'll. It will probably be for end of the week or something that I'll.
Okay.
I'll do.
That's great. Okay. So those gets us into so those two things. One's happening gets us into going from watching NF deployment, sniff through all the config refs or parameter refs, and then executes transformations, and bring all the way up to Flux. So that's the workload cluster side things. And so the one big thing missing is the management cluster side stuff. We don't expect to change anything yet at this point in terms of adding any CAP functions and things from vendors. But
you'll see tomorrow, Stephen, that the same tooling is used. So in my demo tomorrow, I'll use exactly the same tooling for the management cluster.
But then you have to hook that up with the specializers.
This is the specializer.
Okay. Oh, you're changing the specializers into basically just executing.
Yes, because I don't even so for anything we did in R1 and R2, I don't have to write any CAP function.
Because right now your DAC is basically replacing CAP functions in a way.
Yes,
okay.
I think that's one use case. It's more than that, but I think it's one of them is I replace CAP. Yeah, actually.
Okay.
But for example,
Go ahead.
I don't know whether it's a good thing or a bad thing, but so the thing is that one of the big advantages that I see is that you don't have to write any, let's say, Go or Python. You don't have to write anything, just these notations that I was showing last time, right? That's all you have to do.
Okay.
And so the speed at which we can act is going to be way bigger.
Yeah. So that would be great because that. Yeah, I don't know. Well, so it depends on whether or not the adding vendor stuff, it's already working anyway, right? So if there's additional vendor extension CLs inside a package, the specializer automatically add those into the config or the parameter refs anyway, right?
Yes.
So
that's correct. So and here it's just the package the DAG will do it for you, right? So it will just see, okay, you have I see this thing, okay, I need to add it there without you having to write code anymore.
Okay.
So
that's good. That's a good next step. To add on to extension CLDs that generates the dummy CLs, and that would we sort of get that either for free or all they have to do is write another YAML that will be fed into the DAG.
So you have to update. So every time potentially if you add a vendor extension and you need to do something special with it, right? If it's like just basic and you don't have to do anything with it, you don't even have to do anything there, right? But for example, if you need, for example, to change a parameter based on some other information, then you have to, of course, add that thing inside of that package, right? So that transformation, if you will, right? And
right. So if you want to change from one resource to different sets of resource, or aggregating different sets of resource into another set of different resources, then you have to execute this.
Yes, but the only thing you have to do is write that KRM and with these mappings, right? So that's all you have to do, right? So
that's the goal. Yeah. So if that happens, great. Go ahead, Akash.
Hi, Stephen. Stephen, I think we have moved on to the implementation side, but sorry to be repeating again the point which we discussed last week. Have we finalized on the Flux operator, and is this acceptable from the vendor point of view? Because for the RAN workloads where the cloud infra, from the cloud infra point of view, at least I know that we have a much stringent cloud infra requirements, and so we seem to be adding more and more such CI/CD tools like Flux, and already we have config sync to deploy Flux to the workload cluster. So have we, from the vendor point of view, like there are a lot of vendor folks in the call, so they can let me know if this is okay, if this is acceptable, or do we want to rethink on that? Because basically the trade-off, as pointed out, is we cannot. I don't think we have the flexibility to easily change it back if we take this call now.
So last week I think Bala raised the point of whether or not we want to run any Flux components on workload clusters. And right now you're asking, in addition to that, whether or not we actually worried that we have too many resources loaded into SED on a workload cluster.
Yeah. Essentially, we are doing some CI/CD, right? I mean, we are adding these to the workload cluster. We already have config sync to deploy Flux as well, and we are building the intelligence on the workload cluster now, which is fine. But my point is it all acceptable from the vendor point of view? Have we had this discussion? Sorry, maybe I missed it. And another question I have is a Flux basically also used in day one operation, or is it only on day 0? I'm a little confused on that.
Day 1 in this case, yeah.
Okay.
I mean, we try to not do it beyond this, but then we haven't defined our day 2 workflow that well yet as a community. So I mean, I'm hoping we don't have to use Helm at all. Helm should not be involved on day 2, but then that's a much bigger conversation once we get to day 2 discussions. I think you have a good point. So I guess there are other people who are trying to comment on this too. So go ahead, Kieran first.
Yeah, and I don't think Helm comes anywhere near day 2 anyway, so I don't think that's a worry. But I think the question of whether or not you run Flux on the workload cluster or whether you run Flux, essentially, I guess it's doing a job, as in, I guess, monitoring the Helm release custom resource and then actuating that. So if it isn't doing that job, then something else will have to run and do that job in its place, which would be a wrapper around the Helm client library. In my view, now that doesn't need to run on the workload cluster. We've also done, you can run it on a more central cluster and target it towards other clusters, so you can federate it somewhat. But I think there are trade-offs between.
Yeah. I mean, it doesn't. It's interesting because it kind of makes our workflow kind of strange. So the Helm execution happens if it happens on management cluster, which I'm sure Flux can support very well. The problem though is the NF deployment plus your CL, the vendor CLs, which is processed by operator today, would also have to move into management cluster, so they would actually be able to know what it's supposed to do. If it's purely just transformation of resources and then invoke Helm, there is a possibility we can do that, but then that logic becomes specialized logic instead of operator logic, which it may be doable, but then we have to run through more cases to see how it is. I guess Wim has a comment on that too. Go ahead. Hello, Wim?
Sorry, I pushed my wrong button. So I think most people said it, but I think we will run what I call a GitOps tool, right, on the workload cluster, as far as I can see, and it will be the right one for the job, right? So if you need Helm with all the hooks, then it seems there is only Flux that is able to do the job. So we will be tied to that. If you don't need that, you have other options. And if you don't need Helm at all, you also have options. So I think, from my perspective, I think in a real deployment, you will only deploy one GitOps tool at the workload cluster, and it will be the one that serves the purpose for the workloads that are running there. But Flux has an advantage over others at this stage because of that hook thing.
Yeah, so that's one. But then I just want to know, Akash's question seems to be also that we want the Helm executions to be done on management cluster, such that the workload clusters only get resources that are pertaining to the deployment of the network functions. So none of the vendor extension CLs and other things needs to be loaded. So that's more like a workflow problem in terms of when or not.
Yeah, but that also doesn't give you the Helm hook capability, right?
Yeah, no, it doesn't. No, it doesn't.
So I
on,
think
on the Flux side, yes.
Yeah, so I think from the moment you have you're tied to hooks, you're kind of tied to Flux, it seems. But Tal has also a point, I think.
Yeah, go ahead, Tal.
Yeah, I feel like we're mentioning a whole bunch of tools, and it might be useful to divide them into two groups. There are tools that are a big part of the cloud provider's platform itself, and they come with support and everything, etc. Right? If you use Google, you're going to get support for config sync, right? If you use Red Hat, you're going to get support for ACM and Argo, right? That's part of what you pay for, what a customer pays for. Now, there are other tools that we insert into things and they're not really supported, right? You know, Helm, I don't know how much Helm is supported by different providers, right? If you have an issue with Helm. So I think when we start picking tools to use with Nefio, I think we need to think about the different ones, right? So if we decide, for example, to use Flux or support it, the question is which customer would actually get support for that, right? Every one of our components becomes a part of the bill of materials, right? That we need to think about in terms of what customers are actually paying for and the support they're getting. So it always worries me, you know, on the one hand, we can find all these very cool open source tools that can help us. You know, the future of Flux right now, we keep using it as an example, but its future right now is especially unclear. But yeah, we need to put that into consideration too, in terms of our opinions and what we actually support, right? Helm is ubiquitous, but I don't know how many customers actually get, you know, real first-class support for Helm if there are issues, etc. I guess it comes from the vendor, right? You know, if you pay for, I don't know, Nokia, a packaging system, and the Nokia product comes with Helm charts, I guess Nokia offers support for that, right? Sorry for picking a Nokia, Wim. Just
well, I mean, Helm the tools is supported by Microsoft, I guess, if you're paying for them, but still.
On Azure? Possibly, yeah. I don't even know what the level of support for Helm in Google is. I know that there is Helm support in config sync, which, by the way, we've never used. We've never really experimented with and tested, even though config sync has been our reference implementation. Something worth looking into. Although, again, config sync is pretty much, you know, if you use Google Cloud, you're going to be using config sync. If you use other clouds, sure, you can deploy config sync, but probably they won't get the same level of support, right? Kieran, your hand is up probably on this topic.
Go ahead, Kieran.
Yeah, no, I mean, I think as far as I recall, anyway, one of the reasons why, from an Ericsson perspective, anyway, we've been using Flux is based on the fact that config sync, for example, uses the templating mechanism, so it doesn't fully support the Helm hooks, and similarly for Argo. But I think we've also had this discussion that, you know, we're pointing at Flux as an implementation that uses the Helm client library directly, as opposed to using templating. It's possible to sort of re-implement that in the context of Nefio, or to, you know, provide some kind of standalone operator that handles things in that way. So it doesn't necessarily need to be, you know, any one of those tools. We could have a common sort of approach that works with any of the tools, would be the ideal scenario.
Yeah, let me add a point to that. The specific component in Flux that deploys Helm is extremely simple. I mean, honestly, I think anybody here who wrote an operator can write it in one day. It is something that could be potentially just owned by Nefio, right? We can have our own like workload Helm operator. All it does is takes a CR and runs Helm locally. It is almost trivial to write. So we talk a lot about Flux in this component, but we can talk about it without any relation to Flux, right? Just having some sort of Helm operator on the workload cluster, which, by the way, kind of goes back to Helm 2.0. Helm 3 did away with a component that was called Tiller. There used to be a component in Helm that was exactly that, and it got removed because probably for good reasons. I think Helm works better as just a command line tool without a server component. But if you need a mechanism to deploy Helm at scale, then suddenly you can reintroduce something like that. So yeah, let's just keep it in mind. We're talking about something really, really straightforward in Flux, and not really Flux as a whole, just that specific thing. Kieran, your hand is still up if you want more to say.
Yeah, I probably did. I was going to say something around Etsimano architectures for supporting Helm, which is, I guess, how we're currently deploying workloads into operators' environments. But I guess Nephew is looking at moving beyond that approach. So, yeah, I'll take my hand up. I agree. So, with a certain extent, Tal, on your the triviality, I'm not sure that it's 100% trivial in terms of what Flux does, but it's certainly not I wouldn't say it's sort of rocket science.
Yeah, trivial is a relative term, but yeah, Flux does other things too, and that component does fit into the rest of Flux. But if all we need is that functionality, then I think it's pretty straightforward.
So I guess in the context of this discussion, that my understanding is that we're using Flux as an example of an operator that treats Helm charts as a first-class citizen, showing that we can, execute this, provide this type of SDK support using Flux as an execution or reconciliation agent to do that task. And we need to take that conversation further then once we've proven the concept.
So for us right now, this is a reference. But then if there's opinions of moving it something different, it's good to think about it. I guess that's what Akash's point is. So Akash, do you have any suggestions after making that point?
Yeah, I agree. But the primary point was that do we want to have this on the management cluster or on the central cluster or the one which, because the decision we are going to make now, if we can, I don't think we can easily revert back later for any later during RAN deployments or anything like that. That's my initial point, not more about the tools, let's say. Yeah.
The concern I have actually, if day one is done on management clusters and day two onward is done by workload cluster operator and workload cluster, is that there probably is overlap on resources between the two, and then it'll be allocated halfway on the management cluster and be allocated halfway on the workload clusters. Let's say IP address block, right? So we identify an IP address block, we pull an IP address, we put it, because we need explicit IP address when we deploy the Helm charts. So we identify the one IP address we're going to use, and then executes the Helm charts, and then at the same time we send a NF deployment with a block, for example, to the operator, so the operator would be able to do that locally for day two operations. In that case, there seems to be uneven overlapping operations, and there seems to be complications between synchronizing between the two. So that would be one of my concerns, if anything. I guess
So when IP, I didn't understand the example.
So what Akash basically, I would think. So my interpretation of what he said is, let's do all day one on management cluster, so we don't have to do any Helm executions on anything other than the management cluster. So we will execute, the Helm execution happens on management cluster, pointing to the workload clusters, and it basically just deploy the resources, deployments, safe set, daemon set, whatever, persistent volume, so on. So those needs to be there anyway, so that they're executed on workload clusters. But then the moving forward thing is that the day two operations are not done by Helm, will not be done by management clusters, or majority of the work will not be done by anything on management clusters. So we want operator locally able to react to, let's say, some network function LCM events. So if a resource, such as IP address, that's an example, if a resource get allocated, because day one we need to allocate that resource already. So that was allocated by management cluster. But then we are giving them a group of that resource to the workload clusters, NF operators, because we expect them to locally able to handle any LCM events for their own network functions. Then you overlapping operations between the two, because they're two different clusters that are basically like now allocating IP address. And B, I think it's very hard to like indicate that and synchronize it between the two. So that's one of my concerns, if anything at all.
Yeah, see what I mean? I think from an IP perspective, that this particular example that you took, yeah, two people managing it is going to be a problem.
Yeah.
But I can also think of other day 2 operations where there is no.
Well, not to mention things like, oh, what if I want to change the replica set of my deployment? And right now, if Helm is running locally, then I update the Helm charts, and then Helm takes over. So at least that part of day 2, I'll let Helm do it. And then any preparation work for the infrastructure, I'll do it before I change the replica set, right? So the changing replica set becomes just a operation of day 2, because I have a way to get to replica set setting on the deployment on the workload clusters. Whereas in the case where the Helm execution is purely on management cluster, then the replica set needs to be retrieved somehow by the operator, independence of the Helm. So I'm not even familiar enough with Helm charts that whether or not you would be, does Helm like owns the resource after they execute and is untouchable by someone else. So I'm not actually even sure. So because I know config does that, for example, but then obviously they're not the same thing. So config does that when they apply the resources, they lock the resources, and no one else, no other controllers and things would be able to modify that resource that is deployed by config. So I'm not sure if Flux or by extension Helm itself, whether or not it has claim ownership of the resource. Even if it's doable, it's pretty hairy. So there are things that I would be concerned about by doing that, because actually John was a major proponent of doing that back when we first talked about Helm support on this context, and then I kind of raised that concern even back then. But anyway, then it's a legitimate thing. So it's kind of nice to kind of explore what it is as a reference. Let's get something going first, and then.
So I could partially maybe answer the question, right? So in the move from Helm 2 to Helm 3, that's kind of exactly what they changed. With Helm 2, there was an operator that basically owned everything, right? So very similar to how we work with operators, right? Think of Tiller as a generic operator. So it owned all the resources, right? When Helm 3 was introduced, they went to client mode, and the way they handled it is kind of like kubectl handles things. So, if you work with kubectl to like make patches and updates, it inserts a lot of its annotations into the resources, right? There's that kubectl previous revision, I forget what it's called, but it basically shoves the entire resource into JSON into an annotation, right? To keep track of changes. And Helm does the same thing. So if you deploy a Helm chart right now, you'll see it adds a lot of annotations to all the resources, right? To keep track exactly of versions and to be able to do these diffs for day 2. But all of that relies on the Helm command line tool interpreting those annotations, right? So the semantics are entirely client-side. There's nothing on the server, right? You can change anything you want on the server, but if you run the Helm tool again for day 2, then it's going to look at those diffs according to annotations that it recognizes. If you delete the annotations, basically it has no idea what happened, right? So that's kind of in a very short nutshell, right? How Helm 3 does day 2 changes, right? It keeps track of those annotations for it, so it knows which version of chart, when it was done, what the revision is. So it's able to do kind of diffs, right, between the last time you ran it and the next time you ran it. But yeah, generally, I think I don't know our appetite for exploring Helm support for day 2, right? I think
no, we don't for sure. We don't want to. We would like to discourage that.
Right. So if we minimize Helm to just a day 1 tool, then all of that kind of semantics for annotations and ownership kind of goes away. We just assume that once it's there, we own it. But what does we mean? I don't really know, right? Because if a network function was packaged with Helm, I don't know what the expectations are in terms of day 2 support using Helm. I mean, every product has its own documentation on how to do day 2 changes. Yeah, go ahead, Kieran.
Yeah, go ahead, Kieran.
Sorry, trying to find the unmute button. Are we talking, when we talk about day 2 here, do we mean like upgrade scenarios and that sort of thing?
So yeah, something like you will be able to scale up by yourself, right?
Yeah, scaling, healing.
Yeah,
those are kind of the common
updating, node migrations, stuff like that. So this is the LCM, the lifecycle management of your own network resources, network functions.
Okay, I would have thought scaling would be something Kubernetes does, kind of where you mean like
Yes
pod
and
autoscaler
no.
or
So if you use Multis, for example, you have to create another pod that has the IP, the secondary interfaces. You have to give them IP addresses. Kubernetes has no idea what the hell Multis is, so you have to do it.
That's fair enough. Yeah. Okay. I think I had a different view of what you meant by day 2.
Yeah. So horizontal scaling of a pod. Yeah. So horizontal scaling of a pod. That would easily be done by Kubernetes. But then network functions has other requirements. So those other requirements need to be executed by the operator. It's what our value is. Basically.
Yeah. And I guess there is a handover because you can have Helm, which will deploy an operator, and then the operator itself.
Yeah, the replica set change is the simple part. The part before then is the tougher one.
Yeah. I guess one of the things we always said that Helm was a kind of a stepping stone to support the 95% of network functions that are deployed using Helm today, but it wasn't necessarily the wanted position. So we should, I guess, avoid trying to over-engineer a solution to fix.
No. So we do agree, as Tal talked about many times too, that obviously this is a day 1 only thing. So we agree to use Helm because we know all of you folks on vendors. So I have put a lot of investment on Helm. It will be unfair for us to say, even day 1 you have to change. And as we talked about at the beginning of the year, it's at least for our 3.5GC experience, it's not like we're adding that much value on day 1 in Nefio. If anything, that actually I could even point some weaknesses, if anything. So we do want that Helm support to make it easier for vendor on board, and we do see advantages of using it. So beyond that, we don't want you to do more complicated day 2 operations off of Helm. Helm is not a good tool for you to use that anyway. And B, Nefio is supposed to fill that gap, particularly for telco workloads, right? So that's the idea. This has always been the idea.
But Stephen, the issue is this, right? I mean, the issue I see is this. Let's say we do the day 1 operation, and then there is some updates to the thing. There's a patch or anything. But the vendors will again give the Helm chart, isn't it?
Yeah. So if you upgrade your software, so you now point to like a different image or different version of that image. It's an update of a resource that triggers the Helm update on our side. So some of the things will be a Helm update. That's why I was saying in the current POC that we plan to do, the Helm executions happens on workload clusters, and therefore we group that into part of the things we may have to do on a day 2. Whereas if we push it all the way up to management clusters, then we have a clear distinctions between day 1, day 2, and if any of the day 2 operations requires Helm changes, Helm chart changes, or values the updates on Helm charts, then that would means that we still have to go to the management clusters to execute them. So this is the part where we have to kind of trade off.
Yeah, but let's look at the system in a OSS BSS in a big system. How network operators actually wants to do it. So let's say let's take an example. I don't know, a big telco or even a small telco, doesn't matter. They've deployed CU and DU.
Yeah.
And let's say 1 month down the line, they obviously the deployment comes all the way from the OSS systems. OSS systems may talk to some SMO, SMO may talk to an FEO, and FEO will, you have deployed it. Let's say it's all based on Helm. And let's say there is a new patch for it. I'm not even talking about update. I'm just talking about 15 days down the line, there's a patch for it. So how are they going to apply the patch?
Patch to the network functions.
Network functions, yeah.
Okay.
So let's
Patch
say
workload.
network to the back functions, and they gave them the new set of Helm charts. Let's say they may give just one patch, or they may, let's for the simplicity's sake, let's assume they gave them the entire package, which includes certain patches, including the very example that you took, Stephen, which is number of replica sets.
No, so there's a difference between updating the Helm charts, which you have to run through the whole workload, through workflow, or just changing a value on the Helm charts.
Yeah. So from an
in which
operator
case
perspective,
we should be able to, if we put the executions on the workload clusters could do it. If you update the Helm charts, you have to rerun the whole SDK for crying out loud, and then generating and then push it into Gig. And then the SDK would then be executing a different Helm charts. So that's a full bloom operations. But then if it's just changing a value, the point is, if there's something that we can locally detect, or if it even should touch the management clusters, that changes would be very harmless, because you may make some modification of the CL, new package push down, and then the operator may have because the operator, which is vendor specific, has the knowledge to know how to do that upgrade in a way that wouldn't be as disruptive, if you will, as it would have been if you push the entire thing down. So that would be what I would view as a value. And then updating a Helm charts, which hopefully doesn't bring down all the pods during that time, would basically be part of doing the execution, of responding to that change, rather than saying that, oh, we have to involve the entire workflow again, just to get it down.
So basically, you're differentiating between two cases. In one case, even if it's a day 2 or whatever we want to call it, it may come all the way from the top, where the management cluster is involved, and we are again re-rendering the Helm charts. That's one, that's bigger workflow. Then you're also talking about something more surgical, where somebody can directly go there with enough privileges and tweak the values. That's what you're differentiating, right? So
yeah. So in your case, you're saying that you want to push a patch, so that's an image update.
Yeah.
And in that case, you have to bring down things, and that is an update of the Helm chart values. So we would correspondingly have probably vendor extension CLs that would allow you to specify the image of a particular pod within your network functions that needs to be updated, and then that get pushed, and then in that case, for example, let's say for argument's sake, the operator is smart enough to know that it only affects maybe one of my 8 pods that are running, for my whatever CU or DU, and then they would maybe only executed a particular chart and things like this. So I mean, they're options once you do that. I mean, you can do that to a management cluster, obviously, but I'm just saying, it's a little more, you give vendor a little more control over things that they want to do to respond to that event. Yeah.
Got it. So on the side note, I was kind of interested when you said config sync locks down the resources.
Yeah, it does.
So even the kubectl with privileges cannot.
Yeah, you would
any
not
changes?
be able to do it. That's right. I've done it many times already. Yeah. So if you push something down to config sync, the only way you can change it is to change it change your resources on Gig, and then config sync will pick it up. Otherwise, you cannot do offline changes. That's one of the, if you will, that's actually one of the value and features. Google, I didn't do it, but then Google intentionally, the team, the config sync team, purposely did that, because it want to avoid other people changing the resources that aren't tracked.
How does it actually achieve it? Just wanted to.
There's a way on API server they can lock a resource to owner. It's very durable in Kubernetes.
Okay. Okay.
Yeah, we can all do that actually, just using kube control too.
Okay.
That
Okay.
it ties up to just the identity of the person executing the kube control.
Okay.
Yeah.
That's what I wanted to know how. Thank you so much. Yeah.
Yeah. So that's a good topic. Thank you, Akash. I guess it's something that's ongoing, but then for now, for POC, we'll go with the simple form, and then we'll discuss of any iterations and evolutions that we need to do, because I clearly, to me, we don't have really a solution yet if we want to shift to the left side completely. So in 7 minutes left, I would like to ask, given that Dijon or Dian is here, how are we doing on in terms of investigating the CLI?
Yeah, hi Stephen, can you hear me?
Oh, yeah.
Yeah, sorry. Well, I started looking into that, but I got quite sidetracked with some other things that we are doing internally. So maybe I can prepare something for the next week.
Okay, that would be great.
I need a little bit of time because I'm hammered with what we are doing internally.
Okay, that would be great. Thank you. Yeah, that's the only.
Sorry, I didn't see your message on Slack today.
Yeah. So I would.
It was a crazy day.
The message was really just there, just because I was
Yeah.
trying to lazy our meeting, but then apparently everyone really loved the meeting. So, but great. Thank you. So I'll pencil that in for next week. Okay, cool. So I mean, I think we are humming along. Seems to have a plan of moving forward. That's the CLI part, which DN is doing, or investigating at least, and then we have a major dependencies on Vim's K form, but then it sounds like it's pretty much there, so it shouldn't be that risky, so that would be great. Anything else from anyone? If not, then thank you. If you have 5 minutes back.
Thanks, Stephen.
Thanks, Stephen. Yeah.
Thanks. Bye.
Bye.
Bye-bye.
You. Bye.
Bye-bye.